So in this video, I will be discussing Codeforces educational round 168. Okay, so I will be discussing first four problems of this set till problem number D. So let's now discuss problem number B because A is easy. So let's now discuss it here. So in this question, you will be given a grid of size 2 of rows 2 rows and n columns. Okay, and you are given a definition of a region. A region is pair of cells such that every cell is reachable by every other cell and you cannot traverse diagonally. Okay, I cannot traverse diagonally. So what you are given that in the given matrix you will be having at most one region. Okay, I will be having at most one region. For example, if I like, for example, if this region, for example, if this region was a free cell, if this region was a free cell, then you know one thing that this whole would be a region. Okay, then this whole would be a region because every cell is reachable by every other cell in this region. Yes. Now, if you block this cell, which is already broken, but yes, if you block this cell, if you block this cell, then you know one thing that after blocking this cell, there will be now three regions, which means one region is divided into three regions. One region is this, one is this, and one is this. Yes, this is true. Now, this is what a question is asking you to do. In the given grid, you have to tell them how many cells are there such that if you block them, your current region would be divided into three regions. Okay. So there will be only two conditions in this question in which you can divide a single region into three regions. Okay, I will tell you here. First is this, like if your this cell is blocked and your this cell is blocked and every other cell is free. If your this cell is blocked and your this cell is blocked and every other cell is free. Okay, then what you can do, you know one thing that this is a free region, this is a free region, but but if you block this cell, if I block this cell, then your this region would be divided into three regions. One is this, one is this, and one is this. And similarly, if you block this region, your one region would be divided into three regions. One is this, one is this, and one is this. So these are the only two possible cases in which if you block a cell, then your current region would be divided into three regions. So just check these two conditions and you will get the answer. Okay. So let's now discuss the next problem, that is problem C, that is even positions. So I will discuss it here only. In this question, you will be given a balanced parenthesis, okay? And there is a one attribute named cost of a balanced parenthesis. But what is the cost? I will tell you. Like, for example, first of all, write the index of each and every parenthesis. That is 0, 1, 2, 3, 4, and 5. Okay. Now tell me, for this opening parenthesis, where is the closing parenthesis? Nearest closing parenthesis. So the nearest closing parenthesis for this opening parenthesis is at index 3. So what is the difference between the indexes of these two, uh, opening and closing one? That is 3 minus 0, that is 3. Okay, write it here, 3 plus. Now for this one, where is it? Where is its closing parenthesis? That is at index 2. So what is the difference? That is 1 minus 2, that is 1. Okay. Similarly for this opening, the closing is at fifth index. So the overall cost will be 1. Yes. So the answer is 5, which means for this balanced parenthesis, the cost is 5. Great. Now, but you are given a balanced parenthesis, but every odd position is removed. Okay. Now you have to fill this balanced parenthesis such that it is balanced at the end and the cost would be minimum. The costs have to be minimum. You have to return that minimum cost. Hope so the question is clear to you. Now I will tell you the solution, how you can approach this problem. And I think so you can check the balance parenthesis question, which is I think so very much standard classical problem before this question. So just maintain a count variable. I think so it will be enough to solve the problem. Just maintain a count variable. Okay. Now start iterating on this like on this string because it is given you in a string format only. Now if you're encountering an empty space and your count is initial count is 0, yes. If you're encountering empty space and your count is smaller than 1, yes. If your count is smaller than 1, then just put a opening bracket here. I will tell you the reason in the I will tell you reason later. Okay, and increase the count by 1 because for each and every opening parenthesis we will increase the count and for each and every closing parenthesis we will decrease the count, okay, which will represent that number of opening parentheses we have. That is count 1. Again you are encountering opening parentheses. Yes. Now increase the count by 2. Now because you have two opening parentheses, now you are encountering a empty space. If you are encountering empty space and you are having a count, which means there are some opening parentheses behind you which you can close. Just close them. Okay, just close them because this is an empty space. I am closing it. But you know one thing, by closing it, you have to decrease your count because now there is only one opening parenthesis because this one is handled by this one, this closing one. So just decrease the count by one. That is one. Now you are only remain with one pending opening parenthesis. Yes. Now you are again encountering a closing parenthesis. Yes. Now you know one thing, that you are having a opening parenthesis, but now you're encountering a closing parenthesis. Just decrease the count by one because now number of pending opening parentheses would be zero. Yes, zero. Now you're again encountering a empty space, but your count is zero. Yes, my count is zero. Just increase the count and write a opening parenthesis here. Okay. Now you're encountering a again closing parenthesis. Just close it, and your pair is complete. Just make it zero. So this would be final parenthesis string which you will be having, and you can easily find the cost. But how? I think so it is very much easy. By using stack you can count it, you can find it. So let me take another example. For example, this one I can take. Okay, so I will maintain a count variable. Just count here. Initially count is equal to 0. Okay, you are encountering a empty space. Your count is 0. Just make it opening here. Okay, increase the counter by 1. Okay, now again encountering opening. Just write it opening here and increase the counter by 1. That is now 2. Yes. Now you are again encountering empty. Now you one thing. You have encountered empty. Your count is greater than 1, which means there are some opening parentheses behind it, which you can close. Just close them and decrease the counter to 1 again. You're again encountering a you're again encountering a empty space or the closing parentheses. Just close them because you know one thing. There was some opening parentheses which you have closed now. Just close it and write it 0 here. And I think so the string is pretty much similar. So I think so it will be same. So that's how you can solve the problem. And last part, how to find the cost, because you don't have to return the string itself, you have to return the count. Okay, yes. So you can also find it very much easily. Okay, for example, this is a because you know one thing, after this operation you will be getting the final string. Now the part is left how to find the cost of the string. Okay, just maintain a stack and index. For example, this is 0, 1, 2 and 3. Let the stack be yellow. So put the opening parenthesis in the stack, it is 0 index. Again opening, just put it 1. Now you've encountered the closing parenthesis. Just check the top of the just check this is stack. Just check the top of the stack. What index it is? That is index 1. Just store the difference between them because your current index is 2 and the top of the stack is 1. Just store the difference between them, that is 1. Yes, and pop it out. And now you're on this index, that is 3. What is the difference between 3 and 0? That is 3 only. Okay, yes. So just add 3 your answer and pop this 0 also. And what is the final answer? That is 4. So I think that this is very much easy. So that's how you can solve the problem. Where see, I will show the code. This is that only, like maintaining a count variable. If my current parenthesis is opening, just increase the count. If it is closing, just close the count. But if my if I'm on the empty space, but if my count is greater than 1 also, then close that string and decrease the count. But if I am on the empty space and my count is equal to 0 or smaller than 0, then just make it a opening parenthesis and make the count equal to 1. And just this is the final part in which I am just checking, finding the overall answer. Just putting the opening parenthesis with this index at the stack, and if it is closing parenthesis, checking the top of the stack. What was it? And incrementing my answer and just popping out the top one. So that's how you can solve the problem C. Let's now discuss the problem number D. That is very much interesting also. that is maximize root. So in this question, you will be given a rooted tree, and root is always 1. You can see. Now you can perform one operation any number of times in the given tree. And what is that operation? Choose choose the index. Okay, choose the vertex such that it has at least one child, and increase the value of your current node by 1, the index which you have chosen or the vertex you have chosen, and decrease every child in that vertex or in the subtree of that vertex to 1. So what you will tell them, after performing this operation infinite number of times, like any number of times, what is the maximum value with what is the maximum value the root can get? Okay, so I will tell you the question in by breaking into parts. First of all, we will study this. Let me increase it. Okay, first of all, we will study this tree. Okay, for example, the value of this node is I think 3, and this is 4. Now, what is the cost? So, what is the cost of this tree? You cannot perform operation of this root because there are no child of this root. Yes, so you can only perform operation of this root on this vertex. So, how many operation you can perform? So, I think so. Um, I can perform 4 operations. Yes. So after performing one operation, this 3 would be converted into 4, and this 4 would be 5. Oh, okay. This is decreasing. This is 3. Now this would become, now in the another operation, this would become 5. This would become 2. Then this would become 6. This would become 1. And last operation, this will become 7, and this will become 0. Yes. Now what is the 7? If your this was your original tree, if your this was your original tree, and this is 3 and this is 4, and your maximum value is 7, then what is 7? 7 is simply sum of this. Yes, 7 is simply sum of this. Yes, because like this is the one case. If you are having only two vertex, both are connected and rooted at this point, then the sum is similar. Then the answer is similar sum of these two vertices. Let's now increase the case. If root is this is having now two children. Yes, the value of this is, for example, 2, this is 3, and this is 5. Okay. Now tell me, you cannot perform operation on either this or either this. You can only perform operation on this. Yes. So okay, great. Now tell me how many operation you can perform on this index. You can perform at most 3 operations. Yes, but why? You cannot perform operation if your value is becoming negative. You have to stop at this place because this is the condition given in the question. Okay, great. Now after performing one operation, this would become 3, this would become 4, this would become 2, this will become 4. Next operation, this will become 4, this will become 1, this will become 3. Great. Next operation, this will become 5, this will become 0, this will become 2. Yes. So now tell me, can you perform another operation? No, because this 0 would become negative. So the final answer is only 5. Okay, now what is this 5? If I ask you what is this 5? The 5 is the value of my root plus the minimum value among these children. That is 3 plus 2, 5. Okay, now tell me, if you are given a case like this, asking you again, if you are given a case like this, the answer for this case is simply a of I plus minimum of its children. Yes, so okay, great. Now let's expand the case furthermore. You are given a root like this, it's having a children here, it's having a children here, it's having a children here, it's here, and I think so here and here. Great. Now the value is 2 here, I think so 3, 5, 1, 2, 6, 7. Great. So this is the value given to you. Now tell me how you can approach this problem. Like I will tell you that part, but yes, how you can approach this case. Now you tell me how you can like increase. How you can like increase your goal is like to increase the value at root. Yes. Now you know one thing, that you can perform operation on this index. Yes, I can perform. After performing operation on this index, what will be its final value? The final value at this place would be this value, because we have checked this case. This is the case which we studied earlier. Yes. So what is the value of this subtree? The value of this subtree would be 3 plus minimum of both of them, that is 4. Let it make it 4. Okay, now I can erase this because this is no further now need of me, like I do not want this. Now what is the maximum value at this place? The maximum value at this place would be 5 plus minimum of both of them, that is 5 plus 6, that is 11. 11. Okay, great. Now furthermore expanding the case, furthermore expanding, I think so I have forgot a case. You have to decrease the root also, like yes, you have to decrease the root also. Like for example, you are given a case like this, that is at this place and this place. If this value is 2, this value is 3, and this value is 4, okay, the final answer would not be this plus minimum of both of them. The final answer would be, like, let's simulate the case. This would become 1, this would become 3, this would become 2. I think so I was doing, okay, okay, forgot, I think so I was just confused. Yes, let's discuss the case next. So what would be the final answer at this point? The final answer would be 2 plus minimum of both of them. That is 2 plus 4. Answer is 6. Yes. So at each and every place, what I am doing? I am just checking the minimum of its root and adding in a current answer. Yes, adding it in my current answer. But you know one thing, that I am also subtracting the case. One thing, that I do not have to just increase my counter. I have to decrease it also, because by increasing it on root, I have to decrease it on it, decreasing decrease in all of its children. Yes, and let me remind of a case. The answer is not 6 here. But why? Because I cannot erase the vertices, because I have to decrease it also. If they are become 0, because if they are becoming 0, I cannot perform any other operation. Because you know one thing, like if this is my root, if this is my root and this is, for example, 2, again taking the same example, 2, 3, 5, 1, 2, 6, and 7. Yes. Now if I perform operation of these three, let me erase this part. That was just for understanding this. Now let me check the real scenario. What would happen? That if you perform operation on these two, yes, if I perform operation on these two, then every other index would be decreased. Yes, every other index would be decreased. Let's start the operation. Make it 1, make it 3, make it 2, make it 4, make it 6, make it 5, make it 1, make it 0. Tell me, can you perform any other option? The answer is simply no. So the final answer would be 3 only. But how we can calculate the case? I think it will be more easier to check the code only. Now what I'm doing, this is only input part. I will tell you the DFS approach, like the DFS question. Now, like if I am on my route, if I am on my route, yes, like if this is the case, I'm on my route, then I do not have to add the current value. But if the current value is the a array which is given to me, but if it is not the root value, if it is not the root value, then what I will do, I will just return the minimum value from its subtree plus current value divided by 2. Now remember one thing, but why I am doing divided by 2? This is very important case. Why I am doing divided by 2? This is just because I have to decrease the value also. I have to decrease the value of the subtree also. For example, let's checking the same case again. This is root, this is another child, this is another child. I think so. This is 3, this is 4, and this is 5. Now, if I will consider the case, the like if I will consider the case, because if my current value is if there is no, if there is no children of that tree, I will simply return the its value only. Okay, I will simply return its value. So what is its value? That is 4. Return 4. Return 5 from here. Okay. Now what is the minimum possible value of from this subtree? That is minimum 4 comma 5. That is 4. Yes, that is 4. And adding current value, because it's the root. And the answer would be 4 plus 3. That is 7. Yes, I know this thing, but if I'm increased, like I'm repeating the same example, I know, but this is very crucial part. Why I'm doing divide by two? Now, if you know one thing that this is not the case, like if I'm like you know one thing that if I first of all solve this subtree, if I solve first of all this subtree, this would become zero. Yes, this would become zero. Then I cannot perform operation on this tree. Am I right? Yes, I am right. Because I cannot perform operation on this part, yes. Because they are not being removed. If the value is 0, they are still there. Then I cannot perform operation on this root. So I will always perform operation on root. But what is the value which I will be getting from a subtree? That is by encountering it here, like giving it here, giving it back here, and dividing by 2. Why dividing by 2? Because I have to decrease the value that at that number of time only. Okay, so I think so. Hope so. It is 50% clear to you. Maybe not 100%. I know the reason, because if you try to debug the uh, code itself, then you will get the pretty much good idea. So I think that the divide by two case is clear to you, because I will not perform operation on first of all this, then this. I will be performing operation on the whole tree at the first time. Okay, so that's how I can get the answer. So that is the reason for dividing by 2. And just check the other conditions. If it is root only, if it is leaf only, then you cannot perform any single operation. Just return its value to the upper part and find the answer. So stay tuned for the next one and hope so the problems are clear to you. If you have any doubts, just check me, just comment me down and stay tuned for the next one. Thank you.